How to estimate the square root of a number that is not a perfect square. When estimating square roots, you first need to have an understanding of what a square root is. The square root of a number is a value that when multiplied by itself gives the number. For example, 3 squared is 9, and the square root of 9 is 3. When finding the square root of a number, the square root symbol is used to denote the principal square root or positive square root. The square root symbol is called the radical, and the number under the radical is called the radicand. Essentially, taking the square root of a number is the inverse operation or opposite of squaring a number. Know that when finding the square root of a number, you are usually asked to find the principal square root or non-negative root of that number unless otherwise denoted. You know to find the negative square root of a number when the negative sign is on the outside of the radical. For example, if the problem was displayed -1 times the square root of 49, you would take the principal square root, which is 7, and negate it to -7. Essentially, the radical represents the positive root, and anything outside of that is just an operation on that number. So you try, what is -1 times the square root of 81? We'll take the principal square root of 81, which is 9, and negate it to -9. Be mindful, though, that the square root of a negative number, such as -25, is not a real number. The reason is because there are no two identical real numbers that when multiplied together results in -25. 5 times 5 is positive 25, and -5 times -5 is positive 25. The square root of -25 is considered not a real number, and taking the square root of -25 results in an imaginary number. The explanation of imaginary numbers is beyond the scope of this podcast. So it's easy to find the square root of a perfect square that is an integer. But what about square roots such as a square root of 30, which is not a perfect square? In order to understand how to estimate square roots of non-perfect squares or a square root of a number that does not result in an integer, let's first list the perfect squares and their roots. Next, figure out which two integers that the square root of 30 is between. We can see that the square root of 30 is between the square root of 25 and the square root of 36, which means that the square root of 30 is between the integers 5 and 6. This also means that the square root of 30 is 5 point something. But what does the square root of 30 exactly equal? 30 is not a perfect square, so there are no two identical factors that when multiplied together will result in 30. So when taking the square root of 30, it will not result in an integer, which is a positive or negative whole number. However, we can drill down to find the closest two identical factors that when multiplied together will give you 30. Usually, when estimating the square root of a number that is not a perfect square, such as 30, without a calculator, estimating to the tenths or 100ths place is sufficient. Let's try it. For the square root of 30, we found that it is between 5 and 6. We now know that the square root of 30 is 5 point something. Next, square 5.1, 5.2, and so forth, and place it in a table. From the table, we see that 5.4 squared results in 29.16, and 5.5 squared results in 30.25. So the square root of 30 falls between 5.4 and 5.5. We can drill down even more to the 100ths place by creating another table. From here, we can see that 5.47 squared and 5.48 squared results in a number that is closest to 30. But which is the closest? We can figure this out by subtracting. 30 minus 29.9209 is 0.0791, and 30.0304 minus 30 is 0.0304. The smallest difference reveals the number that is closest. So for the square root of 30, estimating to the 100ths place, we see that 5.48 is the best estimate because the difference is the smallest. We can repeat this process and drill down further to the thousandths, 10,000ths place, and so on. We'd be here forever because there is no terminating or repeating decimal that when multiplied by itself results in 30. We can check our result of 5.48 on a calculator and we get 5.477225575051661 and so forth. So 5.4772 and so forth rounds up to 5.48, which is our answer.